Oh, these crunchy things are really lovely. I hope he doesn't find out that I'm having a chomp on his crisps, eh? Well, since you're a puppet, never mind, that'll ruin the illusion. How we doing, everybody? So, while Marty's having a crunch on my crisps, I thought we'd talk about Mosasaurs that actually did a bit of crunching. Did you know that? Oh, you did? Well, there's no point in you watching this video then. There's no point in this video at all. I mean, nah, I'm just joking. So today, I was actually going to talk about some interesting aspects of mosasaur ecology, particularly instances where mosasaurs have actually had to crunch on harder things. We usually think of mosasaurs as eating, a bit softer stuff like yogurt. No, not yogurt. Fish. Fish is a lot better. Yeah. So to cover this, we're going to actually talk about a bit of the anatomy of the skull of mosasaurs. First up, mosasaur skulls, or most mosasaur skulls, have what's called cranial kinesis. That's a condition where the bones aren't actually rigidly secured to one another. They're not sort of, one big block. And this allows for them to actually have a bit more movement. Now, most mosasaurs have this, but actually some larger, more robust mosasaurs, like for instance Prognathodon or Mosasaurus halfmani, they actually have more rigid skulls and have actually lost a lot of their cranial kinesis due to the fact that a larger bite force needs a more rigid skull to withstand the pressures of that bite force. And yeah, if you bite down on something hard and your skull's able to move, your face is going to explode. Yeah, just go boom, big boom, big boom. So in the skull are the chompy bits, the teeth. Yeah, what else are you going to use to eat? But mosasaurs actually have 6 rows of teeth. Being closely related to squamates such as snakes and lizards, and also being squamates themselves, they have 6 rows of teeth. So they've got 2 on the dentary, and they've got 4 in the cranium. They've got the obviously marginal teeth, and then they've got the pterygoid teeth, the ones that are in your mouth roof that I seem to have lost somewhere, and I'll find them. Now, the teeth are considered thecodont teeth, and that means that the roots of the teeth are actually well cemented into the jaw, but this doesn't mean that they're there forever. Mosasaurs actually spit out and replace a lot of teeth through their life. That's why we find so many mosasaur teeth. Mosasaur teeth are probably the most common fossil of mosasaurs. And because mosasaurs were so diverse, there were so many different forms of teeth, so this meant that mosasaurs were very varied in their diets. In fact, some were generalists, some were crunchers, some were crushers, some were cutters, some were piercers, some was other things. They liked a lot, except for vegetarians. They weren't vegetarians. In fact, mosasaur tooth form is so well studied that in fact we're able to put them into certain parameters to measure what kind of food they would have been preferencing. So this is called a tooth guild, and this is where we measure certain parameters of the tooth and therefore allocate where the teeth probably lie within prey preference. So some teeth might be better suited for softer food, some might be better suited for harder food. So today I actually thought I'd give a couple of examples of where mosasaurs have actually chomped into harder food. Now, this doesn't mean necessarily that the mosasaur is built for harder food, or necessarily that the animal it bit into died and became, a bit of food for the mosasaur, but just interesting examples. So first off, here's an example of Pseudospinosaurus, which is from the Lower Turonian Acraboo Formation located in Morocco. Now, this particular ammonite would have lived in an epicontinental shallow marine environment with a whole host of other animals, including other ammonites. You also had crustaceans, you had plesiosaurs, you had a pliosaur there, you had sharks, you had loads of fish. But more importantly, you had a mosasaur. That's right, it's my baby girl, Tethysaurus. Yeah, Tethysaurus bit this one. So the paper in question, Gale et al. 2017, actually noted that this animal was a young ammonite, and based on the size of the bite, I actually estimate that the size of this mosasaur, this Tethysaurus, probably was about 1.5 meters. So not very big. So the bite in question, which you can see over there, that actually was not a fatal bite, so it's implied that maybe the mosasaur that was doing this bite, the Tethysaurus, the young individual, was probably investigating, and probably was like, blah, blah. But it does imply that maybe on occasion Tethysaurus would hunt ammonites. Now, Tethysaurus' teeth, which are sort of classed as piercing teeth, were not well suited for biting into ammonites. But if an animal was desperate, well, certainly it'd go after this. Now, for those who don't know, Tethysaurus was what we call a plesiopedal hydropelvic mosasaur, which meant that the hip was really good for swimming, but the arms and the legs hadn't evolved into the classic flippers that we see in most mosasaurs. And Tethysaurus isn't the only example of a basal mosasaur going after an ammonite. A paper from 2024 actually noted that a Mamites ammonite found in the Lower Turonian rocks of Italy, so around the same time as Tethysaurus, maybe a little bit later. So this animal seems to have been attacked by a similar mosasaur to Tethysaurus, most likely a Jaguarosaurine mosasaur, and the only Jaguarosaurine mosasaur that seems to fit the bill at the time and place is Romeosaurus. Yeah, no Julietsaurus still, just Romeo. So Romeosaurus was another plesiopedal hydropelvic mosasaur, which meant really good at swimming, but still had the terrestrial hands. But at the end of the day, it does show that these basal mosasaurs seem to be taking on ammonites, maybe more than what we think. The fact that we have 2 rare instances of basal mosasaurs going after ammonites, that's pretty interesting. And it does appear that this particular individual of ammonite did succumb to the injuries. It does seem like there was 2 attacks by the mosasaur, but a reanalysis could actually prove us wrong. But anyways, mosasaurs didn't stop biting hard things, they kept going with it. And a pretty common place to actually find ammonites that have been bitten by mosasaurs is the USA and Canada. Now, many papers have actually covered the topic of nautiloids and ammonites being bitten by mosasaurs, although there was a slight critique in the 90s suggesting that actually the bite marks were actually home scars of limpets. But in the early 2000s, this was later refuted and actually shows that, mosasaurs actually bit ammonites. And one of the main key differences was the fact that nobody could account for the pterygoid tooth imprints. So either these were limpets that just so happened to form the shape of a mosasaur's jaw on the ammonite, or this was a mosasaur that was biting ammonites. But hey, let's get away from ammonites for a bit, because mosasaurs have been biting into other hard things. In fact, a 2018 study actually showed that an Echinocoraus, which was a type of echinoid that lived during the late Cretaceous, particularly during the early Maastrichtian, so maybe about 72 to maybe 70 million years ago, around that time. Well, this individual of echinoid actually appears to have survived, a mosasaur attack. So it appears that the animal that bit it may have been actually a prognathodon, or a very similar animal to prognathodon, particularly Prognathodon solvii. And if it was so, then Prognathodon solvii actually had more robust teeth compared to Tethysaurus and Romeosaurus. So it just appears that in this instance, the Prognathodon may have nipped the echinoid, and unfortunately the echinoid maybe either got away or the mosasaur didn't bother, going after it. But it does show that echinoids were a prey item of mosasaurs. Now, there actually were some mosasaurs that were specially designed for crushing and crunching, and this includes Globidens. And Globidens was different from other cranial kinetic mosasaurs. This animal had quite a robust and fused skull, so this animal was basically built for crushing. And in fact, a 2007 study shows that a Globidens individual from the USA around about the Upper Campanian, so maybe about 75 to 72 million years ago. Now, this animal actually had the remains of 4 different morphotypes of the giant 1 meter wide bivalve known as Inoceramus. Yeah, basically, imagine having that for a mussel at the restaurant. You wouldn't finish it. You wouldn't finish it, would you? No, you wouldn't even be able to swallow it. But it seems like Globidens seems to have not just eaten just the soft bit inside, but the shell as well, as there was partial bits of the shell actually found within the stomach contents of this particular individual. And it shows that some mosasaurs were actually shifting to eating harder things, and harder things became a prime area of their diet. It's been noted since the late 1800s that Chironidens has been associated with hard-shelled animals, including bits of echinoid fragments found within the jaw, although this seems to be more that the echinoid fragments were deposited there after the animal had died. But in fact, this was further cemented in 2005 with a study using a mechanical Chironidens to actually test how powerful of a bite this animal could exert and what its jaws and teeth were well suited for biting into. And yeah, stuff like lobsters and echinoids were actually on the menu, so yeah, Chironidens, small little crunchy boy. And it wasn't just hard-shelled invertebrates that mosasaurs were going after, they were actually going after hard-shelled vertebrates. Turtles. Yeah, turtles. The only one you can really think of, isn't it? Be honest, yeah, it is. Now, there's actually been several examples of late Cretaceous turtles being associated with mosasaur remains or having evidence of mosasaur attack on them. Now, the big turtle Allopleuron, which is from late Cretaceous Europe, mainly the Maastrichtian, but it did survive into the Cenozoic. Now, there's a couple of examples from Belgium that actually show bite marks, possibly from the Tylosaurian mosasaur Haenosaurus. So it does show that Haenosaurus may have incorporated turtles into its diet. And in fact, the North American cousin of Haenosaurus, Tylosaurus, actually has one specimen that shows turtle bones from the turtle Protostega, quite a big turtle again, actually in the stomach contents of Tylosaurus. So, like its European cousin, Tylosaurus probably would have implemented turtles into its diet. And Tylosaurian teeth, they are quite robust, but not robustly built for crunching, but it does seem that they were able to do the job in terms of turtles. Now, the final example I want to go through is Prognathodon overtonii, also known as Brachiosaurana overtonii, go see my video about the almost reversion of Prognathodon. But this example comes from the campaigning stage of Alberta, and in fact has a beautifully preserved specimen, almost complete, and this animal actually has stomach contents that includes bits of maybe an ammonite, a fish, and a turtle. But this animal seems to have actually eaten the head of a turtle. So this thing just, like its cousin Prognathodon kianda over in Angola, it was a headhunter and went after a turtle. But luckily for this animal, Brachiosauriana was actually well built with robust teeth designed for crushing and crunching things, so this turtle was easy. Which makes me think, why did it go for the head? I mean, the nutritious parts are in the shell. It's like cracking over a Kinder egg. I don't know, I don't speak Mosasaur. But anyways, guys, I hope this was a great video, to watch. I hope it was educational. I hope this sort of opened your eyes to, Mosasaurs, they ate everything, basically. I mean, I know that's a given, but yeah, they sometimes went after harder stuff. I mean, I'm not going to go and eat a brick. It'll be too hard on my teeth. I'm just going to stick to soft foods. But anyways, guys, hope you had a fantastic day. See you later. Ta-da. Bye.